as I said at the end of the last video, the first thing we need to do is get everything on the left side so that we're comparing to 0. So I'm just going to subtract that 3a over to the left side. So we'll have a squared minus 3a bigger than or equal to 0. Again, comparing to 0, we're now talking about the signs of things. Are things positive or negative? And we've got rules for how signs interact. All right, so now I want to get this left-hand side factored. Looks like I can pull out a greatest common factor of a. So we've got a times a minus 3 greater than or equal to 0. Once that's factored, I'm ready to draw a picture of my answer. This would basically be my a-axis rather than my x-axis. And I can see that the zeros of this polynomial would be 0. That's what makes that first factor 0. And 3. That's what makes that second factor 0. So those are the only two places where the polynomial that I have on this left side could possibly change sign. And they divide the number line up into 1, 2, 3 intervals. Now, these are my boundary points. In this case, this was an inclusive inequality. So I want to include those because they do make the inequality true. If a is 0, the left-hand side is equal to 0, and so the inequality is true. So now I'm just going to pick some test numbers from each of these 3 intervals. So let's see. To the left of 0, let's try -1. And I'm looking at the sign of a minus 3, and then the overall sign. I'm just going to write overall because I didn't give that a name. Okay. All right, -1 is negative. -1 minus 3 would be negative. 2 negatives are going to give me a positive. Between 0 and 3, let's try 1. 1 is positive. 1 minus 3 would be negative. A positive times a negative would be negative. To the right of 3, I can try 4. 4 is positive. 4 minus 3 is positive. 2 positives would multiply to give me a positive. Okay, so now which intervals did I want? Well, I wanted where things were greater than or equal to 0. I've already marked off where it's equal to 0. Bigger than 0 would mean positive. So I want these intervals where I've marked off that that polynomial is positive. And so I can see I've got the union of 2 intervals. It would be -infinity to 0. This time there's a bracket on that 0 because it was included. Union 3 to infinity. And again, there's a bracket around that 3. All right, so there's that answer right there. I'm going to just take a look at another example together. Let's just say I was looking at x squared times x minus 1 bigger than or equal to 0. So this one's kind of nice because I've already got that I'm comparing to 0, and I've already got the left-hand side factored. So I can see that my boundary points, which would be the zeros of this polynomial on the left, are going to be 0 and 1. Okay, because this is an inclusive inequality, I would include those boundary points, and then I would just test some test numbers. So if I plug in -1, let's see, we're plugging into x squared, x minus 1, and then getting the overall sign. So the x squared is always going to be positive. -1 minus 1 would be negative, and so that's negative. Between 0 and 1, I could try a half. Of course, anything squared is positive, except for 0, and that's only going to happen here. And then 1/2 minus 1 would be negative, so we're negative here. To the right of 1, I could try 2. That's 2. And let's see. 2 squared is positive, 2 minus 1 is positive, and so we're positive. Now notice, I wanted where we were positive or equal to 0, so I want to shade this. But now this is kind of interesting because my answer now is a point together with an interval. Now when my answer comes in 2 parts, we're used to using a union sign. And this interval should be no problem. That's going to be just 1 to infinity. We've seen that sort of thing before. When we have a single point, interval notation doesn't work super great for that. I suppose I could say bracket 0 bracket, but that's usually not what's done. When it's a single point, we're just going to put that number in set braces. Okay. So we'll use interval notation for intervals that consist of more than one point, but if you have just a single point, just put the number that corresponds to that location in set braces. Okay. So that's one weird thing that can show up in your answers. You will sometimes have isolated points that make an inequality true in addition to intervals that make that inequality true. The one other interesting thing that can happen would be if I had something like x plus 3 squared less than 0. Right off the bat, I can see there's no solution. Okay. Now, if I wasn't sure, I could create my number line, but there would be no solution. The reason is the left-hand side is something that I'm squaring. When I square something, the smallest thing I could get would be 0. If I don't get 0, I get something positive. This is saying that a perfect square is negative. That's not possible in the real numbers. And we are working in the real numbers when we're working with these inequalities. As we were solving equations in polynomials, we sometimes allowed ourselves to work in the complex numbers. But anytime we're graphing or working with inequalities, we're in the real numbers because the notions of less than and greater than are defined for real numbers. Greater than is to the right on the number line. Less than is to the left on the number line. Once we're in the complex numbers, those notions don't make sense anymore. Okay? So, working in the real numbers, this would have no solution. How do I indicate that? Well, what you can do is say the solution set would be the empty set. Your book does this. Just set braces with literally nothing inside. Okay? Don't write anything inside to indicate that there's nothing there. Put nothing there. That means the empty set. It's also acceptable to put what looks like 0 with a slash through it. Either of these means empty set, which is a fancy mathematical way of saying no solution. Okay. So if you get something like this where there is no solution, this or this would be the way to express that mathematically. This is what you'll see in the back of the book, and I wanted to just point that out so that when you come across that, you're going to say, wait, what does that mean? That means no solution.